Welcome everybody to the combined Denver Java and Boulder Java user group meeting. A reminder, we're always looking for DJUG speakers. Email Matt Rabel or myself, or send a message through Meetup if you're interested in speaking or have an idea for a speaker. I'm Greg Ostrovich. I'm the president of the JUG, but we have some really awesome people that make this happen. Just part of that. So we're going to go through some housekeeping announcements, and I have some other announcements, and then we'll bring on Ken to do his talk on Spock. And that's really going to be great. Really looking forward to that. So just a housekeeping announcement. If you need the restroom, you're watching this wherever you're watching this. Hopefully you can find one in your house or wherever you're streaming this. UberConf is one of Jay Zimmerman's conferences. He has the Rocky Mountain Software Symposium and the No Fluff Just Stuff series, which is similar to that. Those are the events that are outside of Colorado. He also has a conference called UberConf, which is, I liken it to drinking from a fire hose. It's amazing, always awesome talks, and he is flying Ken in tonight for a talk. They're the sponsor. I'll let Ken tell you a little bit more about UberConf and then maybe what sessions he's doing for that. Really great conference. I highly recommend it with experiential learning as well. A lot of times they'll do some labs and some other things that you can do before the conference starts to learn whatever you're learning. So some of our other sponsors for tonight are Tech Systems. They sponsor the food and we appreciate their support. Tonight's dinner is sponsored by whatever's in your pantry or your fridge. Courtney Elterman, which is celterman@techsystems.com, is our contact at Tech Systems, and we thank them for their support. JFrog has been doing some awesome giveaways. They usually have a QR code that you can scan or use the bit.ly link in the chat, and we really appreciate their support as well. Apex Systems, they're our beer sponsor. Braden Collip is our main contact at Apex. Tonight's beers are sponsored by whatever's in your fridge or your beer fridge or if you have a keg. Develop Intelligence is another sponsor. They sponsor some Pluralsight training, and we've done that at the state, and it's amazing training, and it's really in depth, and it has ways, metrics that you can kind of evaluate how you're doing. Highly recommend it, and we really appreciate that. Develop Intelligence is a training company, and they're always looking to hire technical instructors who specialize in several technologies for contract opportunities. Those include Java, Golang, JavaScript, React, DevOps tools like Kubernetes and Docker, and many others. Reach out to Bob Clary, and I think his email is on there, bob@developintelligence.com, if you're interested. We also would like to thank Amazon, who's a sponsor. Chris Almond or Sam Ayer are contacts there. They have a ton of opportunities, full stack development, all sorts of interesting things that you could do for them. Reach out to them. And we list all of our sponsors because they give us stuff that we give away. And if you can support them, that helps us by helping them. Okta is another one of our sponsors. They do the Meetup site, and they host the online meeting. Matt Rabel works for Okta, and he does everything for that. And we really appreciate them. Check them out at developer.okta.com. There's all sorts of great tools and some great things that they have out there. NextGen is another sponsor. They're a consulting company for the federal government. NextGenInc.com. Our contact is Dana Esland, and her email address is on the screen, dana.esland@nextgeninc.com. So another sponsor that we have is agilelearner.com. That's Venkat's Romanian's company. And we really appreciate their support. And you can go to agilelearner.com to learn more, and I believe they usually give away a subscription to their website. They do have a conference that was canceled due to COVID that I'm sure they'll reschedule. JetBrains is another sponsor. We give away an IDE, I think 2 actually every week. It's a great IDE. I would call it the Cadillac of IDEs, and it's not just for Java. I have the one that has, it has everything you can have. I do Python and Java in it, but there's a lot of different contexts that you can use it in. So it supports a lot of different things. So there should be some stuff for the door prizes in the chat. So I want to give a thank you to Matt Rabel. He does our speakers, locations. He does these broadcasts. We really, I thank him. If it weren't for this group of people, this stuff wouldn't happen, and I really appreciate it. Mike Zuedo does the door prizes, and he runs the web. He was running the web broadcast sometimes. He fills in for Matt. And Zeddy Chinfeng, who does all of our operational stuff, including social media and announcements. So now I'm going to bring up Chris Woyna from the Boulder Java Users Group, who would like to thank some of the Boulder Java User Group sponsors.
Hi, everybody. Chris Woyna here. This is Buddy the Rescue Cat. We have pretty much the same sponsors. We have Tech Systems, James Corboy. You know, even if you're not looking for a job or you're not looking for someone, they're really good people to talk to just about what's going on in the job market and also the local job market. Rule 4, Cybersecurity and Emerging Technologies. That's where we normally meet. They're kind of the Linux gurus of the Front Range, and they're tied in with a lot of very large companies, and they were the 2019 Colorado Technology Association Award winner. No Fluff, Just Stuff, and Jay Zimmerman, world-class conferences and training, and be sure to check out their upcoming UberConf conference. Agile developer, Venkat Subramaniam. It's great online learning, and he's just a fun, entertaining guy to listen to. I believe we have a few giveaway licenses for that. If anybody's interested in that, just contact me through the Boulder Java Users Group meetup website, and I'll try to hook you up with that. JetBrains, IntelliJ, IDE, same thing. I think I have several coupons for that. If you're interested in that, just contact me, and I'll try to get that to you. First come, first serve. Back to you, Greg. Thank you.
Thank you, Chris. So I'm going to introduce tonight's speaker and the presentation, and I'll remind him to kind of say a few words about UberConf. So Ken Sipe's presentation tonight is Are You Mocking Me with Spock? Spock is a Groovy-based testing framework that leverages all the best practices of the last several years, taking advantage of many of the development experiences of the industry. So combine JUnit, BDD, RSpec, Groovy, and Vulcans, and you get Spock. There are 3 tools Ken uses on every Java project he controls, and this is one of them, and with good reason. This session assumes some understanding of testing in JUnit and builds on it. Ken will introduce and dig deep into Spock as a test specification and mocking tool. Topics will include unit testing, data-driven tests, mocking, and stubbing partial mocks with Spock extensions. Tonight's speaker, Ken is a cloud architect and distributed application engineer. He's worked with Fortune 500 companies to small startups in the roles of developer, designer, application architect, and enterprise architect. Ken's current focus is on containers, container orchestration, high-scale microservice design, and continuous delivery systems. Ken is an international speaker on the subject of software engineering, speaking at conferences such as Java One, Java Zone, Great Indian Developer Summit, or GIDS, and the Strange Loop. He's a regular speaker with the No Fluff Just Stuff Software Symposium tour series, where he is best known for his architecture and dev talk tools talks, and that's where I've met him before. He's awesome. You can find him online at Ken Sipe. And with that, I'm going to bring up Ken, and thank you for coming out today, for flying out to our talk. And a reminder, if you could give a little bit of a spiel on UberConf before you start, that would be great. So a round of applause for Ken Sipe. Thanks for coming out.
Thank you. Yeah, Mike, Chris, Greg, Matt, thank you so much. A lot of fanfare. Let me share my screen. And and when I do, you will see that I'm trying to remember to advertise UberConf. They are the ones sponsoring this for my behalf, or bringing me here, I guess, besides the 4 I just mentioned. What I wanted to remind folks of is there is a $200 discount if you use a specific code, and that code is Uber, as in UBER, 200, as in the $200 discount, and then JUG, JUG. Or for you pilots out there, Uniform Bravo Echo Romeo 200, Juliet Uniform Golf. So with that, I'm going to get started. It's tough to figure out where to start. I don't know the audience. I like to poll the audience a little bit. Also, what I was going to say is that if you like what you see today, this would be indicative of what you would get at UberConf. And if you don't like it, it has nothing to do with what you would get at UberConf. But I'm sure you'll have a good time out there regardless. So I am going to reuse some materials that I've used in the past, in which case I also have kind of a workshop. If you want to dig in deeper, or if you want to follow along, you could go out and clone this. I'll probably spend a majority of my time looking at code that's in this location. It's Ken Sipe and then Spock Java 1. It's a talk I did at Java 1 maybe 4 years ago or so. I've updated it, looks like 4 months ago, probably to the latest Java standard or something, working with Java 11 at that time. So that's awesome. If you want to actually do a lab or a workshop, I also have this other location, which has some labs. It's of course a blank repository for you to work on, but also has solutions. So I'll probably start with that. It's going to be code centric. So hopefully that's okay, but I'm going to start with some slides. So let me jump to that real quick. And I'm not sure how to break this down in polling the audience. So I'm going to have to just make some assumptions. I usually like to have a good time with people on the fly, and that's going to be a little bit challenging here, of course. So Spock, that's what we're going to dig into. I'm an engineer. I'll put it that way. I am an Apache committer as well as a CNCF committer. I have been spending the last, 2.5, 3 years writing Go code primarily. I still do some Java code on occasion. When I do, I write Java code and I test with Groovy or Spock. I also spent a couple of years working with Peter Niederwieser, who is the creator of Spock, as well as Stefan, the creator of Mockito. So lots of good conversations in that space, of course. And then we'll have a little fun with Spock, right? Co-presenting with the nerve-pinching Vulcan. So why don't we get going? Some things are less funny when we're distant, so we'll see. Also, I have a lot of slides that will be good takeaway material. I'll make sure that these are available. I believe actually the PDF already exists in the GitHub repo, so it probably already exists out there. I may not go through all the slides because I want to use the slides to build up enough information for us to just dive into code. I do want to cover kind of the basics of testing and oh yeah,
this is Matt. There's people that in the chat that are willing to do the poll in the chat if you want to ask them there, and then we can gather results that way. It'll just be a bit delayed, right? So ask a couple questions, continue on, and then I can pop in and tell you the results.
Thank you. Thank you very much. I appreciate that. I guess the first poll, if we wanted to have a poll, then is actually probably the most important thing, and it would be worth pausing. I'll continue and we'll get a response here shortly, is how many people are familiar with Groovy. And it would be great to know that you're not familiar, you're somewhat familiar, or you're an expert. So kind of getting a feel for what the audience is. And the reason why, like the question I get commonly is, if I'm going to use Spock, do I have to know Groovy? Well, I'm gonna give kind of a basic understanding as we go through. I think you can avoid it if you want, but I think as we get to the tail end of the presentation, oh yes, from Gradle, so that makes sense. Yep. When we get to the latter part of the presentation, you'll see that there's some benefit to actually knowing some Groovy. So while you can avoid it in some cases, I think when we're using Spock, I think there's some edge areas where I think it's beneficial to be smart in a Groovy sense. Now, with that said, I tend to write Java code for my production and write Groovy or Spock for my testing or for my builds, as someone indicated, Gradle, which is great. And those edge cases are perfect for a dynamic language, and I will provide more details there shortly. But only for Spock. Great, expert in Groovy. Oh yeah, of course, Jim. Good to see you, Jim. Okay, the other thing that I'm going to do is I'm going to, based on the responses that I'm getting, I'm going to also call out things that are very specific to Groovy, and then other areas that are very specific to Spock, just so that we have clarity of what ideas or concepts or notations are coming from what project. We'll see how far we get on these other spots. There's the location, as I indicated, for the workshop that we'll be looking through code on. Okay, an intro. So where did this come from? I think Greg set us up great. What was wonderful about Spock is we take all these things that we've learned through our coding history, whether it's RSpec or behavior-driven development or JUnit, and we can learn from them. And we take all the learnings and we create something new, and that is Spock. So this is intended to be, how can we be terse? How can we be less brittle? How can we be provide more testing, make it easy to test, make it more reportable, those kinds of things in a friendly way. Now, this is targeted to developers. Now, I want to introduce a couple things real quick. First of all, Spock is a BDD tool, or a behavior-driven development tool. There are other behavior-driven tools that we use in the Java world, like JBehave. And in that world, you use an annotation and you're writing Java code. When I'm using Spock, I could use it to create a document or a report that somebody else will read. And we've gone through that gyration. I don't know. I've been writing code for 30 years now, or plus. And we keep trying to do that, and I just don't care anymore. I don't do that. So I'm going to tell you that I actually write my Spock code, my testing code, like I would write unit test code. It's for me. It's not for like a user or like a business analyst or an end user that doesn't know code. I will translate to them or for them what we are seeing. So just be careful. There is probably more you could do with Spock from a behavior-driven standpoint that I'm not going to go into unless you ask questions or we decide to do deep. Also, Spock can sometimes be used as a driver for like web driving. So there's a project named Jeb, G-E-B, and Jeb is essentially a wrapper around Selenium. And there are people who use Spock to actually write tests up or automated tests up against Selenium. I'm not going to do any of that. What I'm focused on is I have Java production code, and I want to test and verify it in a unit or integration style. So that's what we're going to see. If you have other thoughts on that, I'm happy to go into them. So for a baseline, just to make sure we have a baseline that we're all talking the same language, I'm going to talk about JUnit for just a second. I hope not to stay on it for too long, actually. Here's what we might look at as a standard JUnit test. The things to note is that we have a test case. Of course, we could use annotations instead. For the comparison of using it with Spock, I think this is a better way of looking at it. We have a superclass, which is the test case. So we have a test case. It is a collection of tests. Each test is either annotated or denoted by the start of the word test. So we have test calculate and test illegal calculate. We have a setup. We have a subject under test. You can see in the setup, we create a simple interest calculator. We set the rate. I show this because I want to show you what it will eventually look like when we get to writing code in Groovy or when we get to writing code in Spock. So here we have all of the encumbrance, if you will, of Java. We have semicolons on the end. We have some verbosity. I have a statically strongly typed language, as we might expect. We have the assert equals, and hopefully we understand a little bit about how that works. So I don't dig into that unless you ask me. The second thing is when we're testing an exception, what we tend to write is we want to try something. And if we reach the point of failure, we failed. We expected an exception to occur. And we basically have an empty catch block. Again, extra verbosity, but it's a standard way of looking at it. So the question I tend to ask people is, what's the problem with JUnit? What are the problems that people run into? And so what's commonly the result is a lot of repeating code, a lot of verbosity, a lot of fragileness. These all kind of go hand in hand. So the question is can we do better? So we talked about, I have slides for those things. I probably should have dove into those slides. It's entirely illogical. So let's just talk Groovy for a second. If you know anything about Groovy, we would start with the GDK instead of the JDK, which is the Groovy developer kit. And it is included in the kit is JUnit. So unlike Java, which you have to download a separate thing, it's included. We expect this to already be available. And so we can do something similar. We could write basically the same kind of test, but in a Groovy way. And in this case, we're extending the Groovy test case, which is very much the same as a test case. We can start to use some of the dynamic natures of Groovy. So here, instead of having a typed interest calculator, we've defed it. Now, here's the beauty of this. When people have this debate about dynamic languages or strongly statically typed languages, usually the problem is that people have gone too far with their dynamicism. They've created APIs where you have to either document the heck out of it, or you have to guess, or you have to dig into code to understand, and it becomes harder to read, harder to use. First of all, you shouldn't do that. Right? You don't have to do that. You can still use a dynamic language in a mature way, but that tends to be what people's hangups are. Now, when we're using Groovy for, say, Gradle, it's a Gradle build file. It's fairly simple. It's fairly small. It's nice and easy to understand. The scope of it is the right level. The same thing would be true with the test. In this case, it's really hard to get lost. I have an interest calculator. It's not. It's fairly easy to realize that that is an instance of the simple interest calculator we see here. So now we're testing the same code, which was Java underneath, but I'm actually using some Groovy-isms, and I want to call that out. The first is that the simple interest calculator is equal to the simple interest calculator, the creation of a new one, with the rate equal to 0.05. Now, what you should realize at this point is that the simple interest calculator had no constructor. And in Java, if you write a Java class with no constructor, you always get a default no-ard constructor. But wait a minute, it looks like we're creating something with a constructor that takes a rate. And that is true. It looks that way, but it is also not true. What is happening is that we have an ability within Groovy to create an instance of something, passing in the rate as a property. And under the covers, Groovy always compiles down to Java code. The Java bytes that get created actually create the instance of a calculator and then set the rate. But it is a shorthanded way, so we are a little bit more terse, of doing the same thing. So instead of 2 lines of code, I have just 1 simple line of code. So that's worth noting. The second thing to note is that I have what looks like some words here with a comma, but what's going on here? Under certain circumstances, it's possible to write a function in Groovy that doesn't have parentheses, which makes it a great tool for creating like a DSL and things like that. So here, this is the assert equals. It's a function, and it takes 2 parameters, but I could leave off the parentheses if you want. Notice there's no semicolons either. So we're using some of the grooviness, if you will. Additionally, we have this should fail, which looks a little bit odd. It looks less odd now. You have to realize that when I probably created this slide and when I was writing Spock, it's been more than 10, maybe 12 years, maybe 13 actually. So, but back then we had Java 8, and that's all we had, or Java 5 or 8, somewhere in that neighborhood. And this would have looked really foreign. What you have to imagine is that this is a function, should fail, which should have some parentheses here. So the parentheses are missing because they're optional. And this is a closure, which we expect to have an exception. And if we do not have an exception, excuse me, it will fail. The test will fail. So this is actually really convenient. It's super easy to look at. It's more it's more dense, but not in a way that is not readable. It's still just as readable and easier to look at. So that's the first thing, is we've moved to a groovy way of doing things. Now, you don't have to memorize this or even do this. Spock, we're going to go a lot further than this. I want to introduce the fact that there are some groovyisms that we could take advantage of. And the most important one is that we have the groovy power assert. When we have a failure that happens in a test in Groovy, what we get is an output that looks like this on standard out. And so what you can see is that the interest was 25, which is not equal to 20, which was the output of this function calculate on an object that had the toString called on it. Now, again, here, had we created a Java object that had a toString, it would have outputted here. Without the toString, it has the default toString, which is what we see here. So you could have put something very meaningful here. And then we have the amount and the year passed in. So one of the beautiful things, the question I usually like to ask people is, like, when you have a failure that happens in your CI environment, what's the first thing that you do? And I get a variety of answers, but the top answers would be that they either want to, it comes down to they want to recreate it. They want to see it fail in their environment. And what they're really saying is, I need to understand the context of the problem. I want to know, how is it true that the calculation was 20? What are the things that were set? It's often true that when I look at a CI environment that has a power assert involved, I don't actually need to run anything because it has a lot of the context already there. It's exactly what you would want, at least as a starting point for what the failure was. I can see clearly that what the calculation was. Not that it was not 25, but I can see what it is. It is 20. I can also see the parameters that were passed. And if I had toStrings provided into my Java objects, I would also see the values that were outputted there as well. If you had some chaining of objects, it would show that as well. So some really great things. It makes Spock happy. Have you ever seen Spock smile? He smiles for the groovy power assert. So we build some conciseness. It's higher productivity. There's some fluff things added in there. But let's get to talking about Spock. So step one, it is based on Groovy. And in fact, it leverages Groovy to, it's probably the most interesting Groovy project that I know of, because it takes advantage of what we call an AST transformation to do what it's doing. And it's probably the best example of an AST transformation that I know of. So it's just taking blocks of code and restructuring those blocks of code in the process of then running that code. And we'll see some of the magic that happens there. It looks magical is what it looks like. It's clever. One of the things that's very important to understand about Spock is that it is based on top of JUnit. And the beauty there is that wherever JUnit runs, Spock can run. So it already runs in your editor. It already runs in your CI environment. It has the capability of running. Now all you need to do is include the right dependencies, of course. So this is a beautiful thing. I will say that I've worked with at least one organization, and I've had questions come to me after a presentation like this to help a couple of others that were using TestNG. That's been a while, but with TestNG, it has a problem, right? And it has nothing to do with Spock. It has everything to do with TestNG and JUnit can't live in the same phase of testing. So it is possible to have both of those. And I have some literature on that if you need it. Just ping me and we'll get you set up. It is possible to use TestNG and then have separate tests with Spock tests if you want to evolve your testing into Spock. But it would be two separate test phases, and it's an issue with JUnit and TestNG, not an issue with Spock. Okay, so let's dive into, we've included the libraries and dependencies we needed for Spock. Let's get into a spec. What does that look like? And what do we even mean spec? So the first thing is that the spec is a shorthand, a common vernacular for specification. And a specification is a word that comes out from the BDD space, or behavior-driven development space. And this is going to get into an area that some people are going to be like, well, let me pause for a second. The specification and how we're going to use that word is very similar in the JUnit space as a test case, which is the reason why I showed the test case as a superclass of the test case we were looking at. So forgive me if I even call this a test or a test case. It is an easy conversation for people to have, and they understand what we mean usually. But truly, it is a specification, and it is a superclass. And that superclass actually has some functions that are useful in it that we will talk about. But that will define the test case, the specification. And within the test specification, we could have the 4 things that you see here. We could have field level variables. We could have fixture functions or methods, feature methods, and helper methods. And when we say feature methods, what we mean is tests. So specification is a test case, and features are a test. It is the vernacular, as I said, of the BDD space, is that I'm going to create a specification of features that should be created that asserts some feature to be true. When we get into the specification, the first thing to note is, if it matters to you, the JUnit runner that runs Spock is called Sputnik. Sad that it's not the Enterprise, right? No, it's Sputnik. When we have field level variables, what is important to realize is that a field level variable within the class is initialized for each test. This is true in JUnit as well, but most people, oftentimes, a lot of people won't know that. It's a very common or popular interview question, is to know the details around that. Just know that the variables that are defined as a field level variable of a class will be reinitialized each time unless there is a annotation that states otherwise on it, which we will look at in a second. As that second is now, the share annotation is to say that this thing should not be reinitialized for each run of the test. That for the whole specification, we want to initialize it once for all tests or all features that will be run. So it's either a very expensive thing, or for some reason you want to collect. There are times in tests that you may want to collect the state of something. It's a rare situation, but a possible one, by using the shared, knowing that that object will be shared across all of the tests that are involved. And in this case, we want to think of setup spec as opposed to setup. And I'm using some vernacular that are probably common in the test space. Hopefully people are following along. There are some fixture methods, and you see them listed here. What I would advertise is, hopefully it's reasonably easy to understand how this rolls out. But just to give a quick walkthrough, when I create a new specification with 2 features in it, or a test case with 2 tests in it, first thing that will happen is I'll have setup spec. I will have setup. I will test a feature 1. I have a cleanup. I will have a setup. I will test feature 2. I'll have a cleanup, and then I'll have a cleanup specification. So that's the lifecycle order. It is very consistent with what you would see in the JUnit space, so I don't expect to have a whole lot of questions around that, but don't let that cause you to pause. If you have a question around it, then please ask. Now we finally get to like the meat of Spock. This is what I refer to as the heart of the spec, right? Is a feature method. This is the test itself. Now, first of all, to the Java eye, it looks so foreign, right? To the Java eye, it is weird. We have a string, which is the method name of the method, this feature method. So we're going to test something. Now, why would we do this? What would be the alternative? If we look at JBehave as an example, what we would have is a defined test name with an annotation above it. And the annotation would then have a string within it that would say what it says here. But instead of having all of that detail, all that verbosity, we could just say, hey, let's just use the string. The string is the name of the function. So that's step 1. This is the name of the function, pushing an element on the stack. That's what we're going to test. Now, within that feature, there are some blocks of code that we need to discuss. And those blocks of code have special names or labels. They're going to look like Java labels. They're not, but it's common to hear people say that that's what they look like. So I'll go with that. there are certain words that matter. And so here you can see the list of words. It's going to make more sense when we see them in context, but I can tell you here that the most common set of words that go together would be either given, when, then. So given, when, then. Those three words commonly go together, or given, expect. And there's a time when we would use one versus the other, which we will walk through. The other components we'll talk about in detail. I will say, first of all, that the given and the setup are two words that are basically aliases for one another. You could use either one and they're the same thing. Some people still prefer the word setup. It becomes meaningful as opposed to given. So it just depends on whether you're in the space of wanting to articulate things in a more BDD style or not. So be aware of that. Also, those two things are not only aliases, they're both optional. So you could just start writing code, and whatever you start writing in that feature, until it runs into another block delineation, it is the given. So just be aware of that. The other word that's useful to talk about before we run off, before we leave this slide is the and. The and is eye candy, I call it. It's just eye candy. You can use it where you want. It doesn't have any functionality whatsoever. There is some value into the reporting, but I don't use the reporting. So I'm not after creating some kind of human readable reports from my testing. I want to know what the answers are, whether tests are succeeding or failing, and then I will translate that to end users. So when can I use and? Well, you can use the and in several places. One is a given X and at Y. You could also use it in the then X and Y. And you'll see some examples of that. I'll also have some tendencies that I tend to use within my Spock when I use and. I don't always use it, but when I do, there is a specific use case that I use it in that I will call out as we get further in the presentation. Okay, so those are the blocks. Once again, I think they're going to make more sense in the context, so let's drive to that. So imagine the feature body of code that we set up 2 slides ago, and then I'm going to start writing code. So I'm inside the body, and I'm writing code. What you're seeing on the right-hand side, is something that says setup, and below that, something that says given. You're going to use one or the other. It's showing examples of one way of doing it or another way of doing it. You would not do both. So I have setup. In either case, as you see in the given, I have some string information I could adorn to that block of code if I wanted to provide some details. That is also available on the Spock reports. I don't tend to use that as mentioned earlier. So I have a stack that I'm creating. Oh, Matt, you popped in. Oh, you're not. You're gone. Okay. We have a stack and an element. They're basically doing the same thing. I will do one or the other, either a setup or a given. Now, the next slide could be confusing, I suppose. This is the start of the block of code. The next slide is the finishing of that block of code. So let's take a look. So remember, in the earlier slide, we said given. If we follow the BDD style, it would be given, when, then. Here, we have a when and a then. Now, we can see in this case, a when means that a stimulus occurred. Some event occurred for which we expect a side effect. And we want to test or assert the side effect that occurred. So the first question I like to ask, but it's going to be weird in this situation, so I'll just throw it out there, is it's hard for people to see the things that are absent. This is why we like Sherlock Holmes and things like that, because one of the things he's clever at is realizing, wait a minute, the dog didn't bark when this person was attacked. That must mean that the absence of things is really hard for humans to pick up oftentimes. That's why we see it as being super clever when they do. But the question is what do we not see if the previous slide, this slide, and this slide are the complete test? And the thing that you pick up on is, what are we asserting? There's no assert. And what I will tell you is that we are asserting each line in the then clause, the then block. So, and by the way, the word block is what's used in the code, the code that Spock is written in. These would be known as blocks. So the then block. The next thing to talk about is, we'll pause for a second. There is an assertion for each line, and it's a Groovy power assert, which is also awesome. Now, the other thing that's worth talking about is what I like to call the Groovy truth. We need to talk about truthiness. So one of the things that Groovy is fairly well known for is, well, let's take a step back. In Java, what would I do if I wanted to test or only proceed in a body of code if I had a collection and if the collection had something in it? What you would commonly see is if the collection is not equal to null and the collection.size is greater than 0. That is a lot to type and a lot to read that could in Groovy be stated as if collection. That's it, if col. So there is oftentimes, in most languages that I know of, there's always an element of truthiness, something that is not a Boolean, but represents a Boolean in its evaluation. And in the JavaScript world, commonly you often see a bam bam, like an exclamation, exclamation. And what it would mean is convert the truthiness to the Boolean opposite, and then convert that back to the Boolean representation. This is a very common thing to see or do. So we often take advantage of that within the Spock world. It's important to realize the Groovy truth. The second thing that's worth noting is that in the Java world, if I used an equal sign, whoops, sorry, I went a slide. If I use the equal sign as you see here, I am comparing, if I'm comparing two strings, I'm comparing the memory location of those two strings as if they were equal, as opposed to string.equal, which compares the contents of the string as being equivalent. In Groovy, it's the opposite. Well, it's not quite the opposite. The equal is a comparison of the string chart. It's the shorthand. Essentially, you can think of it as what is the most common case that we would want to test, and that's what we use in Groovy. So there is a way of doing memory comparisons, but it's not with the equal. The equal in Groovy means do these two strings have the same character representations in them? So just be aware of that because that could throw people off, and it's really a great utility, but you have to be aware. So this is one of those areas in particular when you have Java production code, but Groovy testing code, you have to switch brains when you're moving from one space to the other. Okay, now we have some conditions. So when, then again, just a couple of other ideas here. When pop, then. Now we can test for certain things like inside of the superclass of specification are functions. One of those functions is thrown. The thrown can have something in it, as you see here on the left, where I have thrown is the empty stack exception. And then I can also assert that the stack is empty. On the right-hand side, I can actually say the thrown provides back a return, which also has to be cased to the empty stack trace. So we know it's the same casing, otherwise that would fail. But I could also then inspect the internals of the object that was created. So I could start to look at maybe exception codes or maybe the strings that were used within the exception, whatever the message is, things of that nature. So this is a really great way of working with Java code with Spock. So let's look at a more complete example. It might be easier. Here I'm going to create, again, a hash map accepts null keys. I have no idea why Java hash maps allow null keys, but it is possible. I also don't know how often you want to test for the absence of something because that list could be endless, but this is a functional test. So we're creating an instance of a hash map. We can actually even make that shorter with Groovy. I could just put a bracket and a colon there, but regardless, we have a map equals a new hash map. When I put a null as a key with a value in it, what I do expect is that then not thrown is a null pointer exception. So this does not throw a null pointer exception, which means that it's valid Java code. So we can test for the absence of something. When would I logically use this? I would use this most likely when I want to assert some things around a Java API, like an API I'm building, and I want to test kind of the things I expect and the things I don't expect. and I want to be absolutely clear that we are maintaining those expectations. I might do this around an API level, but other than that, it's likely I wouldn't use this kind of technique. What I like to do is make sure that people are aware of what's possible, though. All right, so I'm going to break. We're not going to look at mocks for a second. We're actually going to dive into some code. And let's do that now. So I'm hoping that it's reasonably readable. It looks like on my screen, it looks decent. I'm going to go into a number of examples and then go into mocking. So here we have the simple interest calculator. And the thing to note first is that this is a Groovy class. I could dive into it. I'm looking at a simple interest calculator Java class. You can see that up here. Hopefully that's somewhat readable. You can see that it doesn't have any constructor that's defined. And we'll start playing with it. So first thing is things that are here that I didn't talk about in the slides. First, that we have a Spock annotation called a subject. It calls to the eye immediately that this is the thing I'm interested in testing. It is the subject under test. Also, in the Spock reports, this will be called out in the Spock reports as the subject under test. Here we're going to create an instance of the simple interest calculator. We're going to set the rate. You'll also note that if I highlight over rate here, which looks like a property, and I click into it, I actually get the set rate. So under the covers, even though I'm using in Groovy .rate, it knows that it's translated into setting the rate because I'm making the assignment. So in the Java code, it's actually calling the set rate. That's important to realize for those who might be new. Here we have the expect. I have 1,000 is equal to the calculation of these values. I don't think I've run this, so hopefully it's been a while. I don't know if I'll run these each time, but I do want to share some examples. Looks like that succeeded, which is great. You know, ignore these warnings for if you will. Let me just change that and hit run again and see what it would look like if we had a Groovy power assert failure. And we can see here that we had a failure. And again, we know that 1,000 was passed in. This is 2. This is 1,000. It's not equal to 1,001. And we have the toString that was called with the rate, actually. That's kind of cool. I don't know if I've seen that before. Save. OK, so let's go a step further. I'm actually going to add to the body things that we haven't brought out in the slide. So I'd rather just talk in code, if you will. Here we're going to call a simple interest calculator. What do we do different? Remember, I don't have a constructor, so what's this all about? If I highlight over rate and hit enter, I'm on the set rate. So we can clearly see that the editor understands this is actually creating 2 lines of code. I'm creating the instance and setting the rate. But it's easy to read, I think. Here we can say that given expect interest is equal to the calculation of these values, where, and we have the interest equal. Now, this is the first time we use the where body. What is this used for? Well, first of all, this looks really foreign, right? Because here I've got variables clearly, and they're defined after, which seems really weird. We're using the where body, so that's possible. I'm going to delete that line. What do we see here? What we see here is I have a variable that's grayed out. Now, if I was in Java land, this would be a red squiggly, right? And it would say, a Clippy would come out and it would go, nah, this doesn't work. But this is Groovy, and it's a dynamic language. And what this is saying, this is grayed. It's not the red squiggly. It's grayed out. And it's like the editor saying, basically, I don't see it, but maybe. Because it's a dynamic language, it could be resolved at runtime. And it literally doesn't know if that's correct or not. So if you see this, you should question your coding. You should be aware, is this magically being created at runtime? And you need to, or do you need to provide a value? Now, I could have just easily had say def interest equals 1,000. And I can even run this, and it works great. Notice those are the 2 ways of doing the same thing. But why? Why would I? So I could have defined the variables ahead of time. And it's unlikely that you would use a where body to define one value of something you want to test, but it is possible. So here we're seeing the value of the where body. And the value of the where body is to make a data-driven test. In this case, I am defining the variables. So notice what Groovy or Spock is doing for us. Spock is saying this where body is important, and it needs to have an outer scope to the actual test that will happen. And so what happens in the AST transformation is the given is run, The where body is used to create multiple tests. In this case, only one, because there's only one set of values. It defines those set of values and then runs the expectation, which we haven't seen before, in slides at least. And as I mentioned, given when then is that I have a stimulus and a verification. The expect is used when the stimulus and verification are roughly at the same time. You can't tease them apart. And so here is the assert. The assert happens at this moment. So we get assertions for the then, and we get assertions for the expect. And that should make sense, I think. Expect is, I expect this. So assert that. Then is also kind of an assertion statement, right? So this may not make a whole lot of sense yet, although it's functional and works. It's going to make more sense as I give more examples here. Here we have the same exact example with the exception of I have two sets of data. Here I have what looks like to the Java I a shift left operator, but to the Groovy person, we're going to take elements out of this collection on the right, and we're going to push them into the interest or the amount or into a variable of some sort. Here we have two things, and when we run this, we actually get two tests. So you can see how quickly and easily and simply I can have a test that actually I could add more to it. It's good timing on Citrix's part. Now, it's hard to see that there are two tests running, and if I look at the test results, all I see is that things are good. It is possible to use another annotation in Spock, which is the unroll, in which case when I run it, it should show me that there are two tests that I'm running. We'll see what happens here. No, okay, so this used to work, but I'm always on like the latest and greatest of everything. This is a beta of this IDE, but it used to actually show me those results. So just be aware that maybe that's a flaw on my end. I'm not sure, but it should be able to unroll these values.
Now, are you blaming IntelliJ? Is that what just happened?
No. IntelliJ is one of my favorite tools ever, but I am on the beta.
All right, just checking.
Let me see here. The preview. All right, let's go a step further. Take the same example, but go further with it. Now I'm showing you two things at one time. Let's break it down. The where body. Oh, let me go back here. What happens if the arrays are out of balance? What if I have one element and one and three and another? Yeah, it doesn't work. Don't do that. It's a bad. Don't do it. All right. Look, likely that this is not the most optimal way. Let's look at some other options. So one other option is I can actually create a table. Now look how great this is. I have the header of the table is the interest, the amount, and the year. And the cells are, or the rows, or the number, each row is the number of tests. And the cell will be assigned to its value for the header. But on top of that, I have this cell right here, which is a function that returns a value. So I can actually do calculation functions, put that in the cell. What you have to know if you're not familiar with Groovy is that the last line of a function is always returned. So in this case, it's the value of 100, which is returned and replaced in that cell. And I have two rows of data that get that are outputted there. I would rather blame the latest version of Spock than IntelliJ, actually. So it could be that.
That's fine. I'm okay with that.
Perfect. Let's see here. So table, super cool stuff. Here, look at this. I could decide I want a new row, and I added some values. If I hit my Command Option L, it formats. The editor instantly knows that I should format this table to something nice. So it's just a wonderful environment. IntelliJ is. I'll go with that. That aware. Oh, the other thing to be aware of is there's another pipe as well. I could have a double pipe. So sometimes people will ask, well, why a double pipe versus a single pipe? Well, first of all, they're both cell separators. So they both basically do the same thing. They separate one cell from another cell. It means whatever you want it to mean, which may sound weird, but that's true. What people tend to use it for is I have a value and another value, and then a comparable answer on the right. And the double pipe will indicate to them a separation of something that I want to evaluate, that I'm concerned, that's calculated, that I'm concerned with. The other ones are inputs to a expected result. So that's what the double pipes are commonly used for, but otherwise doesn't have any, it's eye candy. It's eye candy, meaning it can mean whatever you want it to mean. All right. You know what? Let me take that example one step further before I go further in this code. And that is, now here's the thing, and I want to prepare you for this. Some of you, what I have found is 50% of you will love this and 50% will hate it, and I don't know which one you are. So you've been warned. What I have here is an example of using a data-driven test that's out of SQL. So you can see my groovy way of creating SQL. You can see I'm using an H driver, which is great for demos or for what I'm doing here. It's going to create in-memory database. Here, because I'm using a newly created in-memory database, the H2 driver, I actually have to create the table on the setup spec, and I have to insert some values into that table. So I don't imagine if you're using this that you're going to actually do that. It's great for a demo. You're probably going to just make a JDBC connection to some database that already exists. And now what the value is, of course, is that every row in the database will be an instance of a test. So here we've taken it to some logical conclusion, and that is I'm going to select the year, the interest, and the amount out of the table I created. And the tuple that comes back, I'm going to break up the tuple into the year, the interest, and the amount. And now this test is the same exact test that is run with a database. And as I mentioned, some of you are in horror and some of you absolutely love it. And you know, you get your vaxxers and you got your anti-vaxxers. I don't know where to go with that. We all got to live together.
Are you unit testing your database? Is that what's going on here?
Well, it's a great example, but I'm not actually I'm unit testing this calculator, but I'm doing it with values that were inserted into the table. So
that makes sense. All right.
Yeah.
That's cool.
Yeah. So I can take it one step further. Here you can see that I'm pulling out values out of the SQL rows, which is, again, using the SQL cursor to pull values out. I'm iterating through a cursor, right? Well, if I'm iterating through a cursor, well, let's go another step further. Let's come here and say that I'm going to do the same exact test, but I'm going to use the simple interest calculate data provider. What is that thing? Well, let's dive into it. And what we find is it's anything that implements an iterator. So if you had a CSV file, if you had XML, if you had YAML or JSON, you could actually create a reader that would create this iterator that would read the files or file and provide data that could then be used in a test that looks like this. So I'm pulling out the tuple, I'm providing a value where I'm testing this calculator that is driven by some other file completely, just any iterator whatsoever. So that's more on the advanced end of things, but super fun to look at, I think. It's a great example of what's possible. All right, let's go back here. So I don't know if that's interesting. Fails with an illegal argument exception. So I have a -1 on the year. So this is one way to test exceptions in Spock. I think another one that's kind of interesting is this one. It's not exactly Spock, it's hand-pressed. So hand-pressed, if you look at the top of this file, I have an import with static imports of hand-pressed functions. So why? What would I use this for? Let's go to the bottom of this file. And we can see there are times when you're doing calculations or you're doing assertions where you don't know the exact answer. You know the range of the answer, if you will. So examples, maybe I'm testing something that has random. Maybe I'm testing a calculation that has precision issues. So what you'll see here, this is one of my common Java interview questions, by the way. I'm going to subtract two values that are doubles. And those values are a 2.0 and a 1.1. Well, what does that equal? Well, in Java, the answer is 0.89999999999. Following the IEEE standard on precision, that's what I would expect. So what we're testing here is, this is the thing we're testing, subtract these two numbers. Close to means that I am 0.9 And in fact, I'm within 0.01 of 0.9. So all I'm testing is that I'm in a range that is close to a certain value. The expectation is that this is 0.9. It's not exactly 0.9, but it is within 0.01 and 0.9. So that can be a handy or useful thing. Oh, also worth pointing out, because Spock is a JUnit tool, all of the JUnit rules that you're used to using, like temporary files, things of that nature, they can all work with Spock. So that's also likely useful to know. All right, that's the basics. Do you guys want more? This is where everybody goes, yeah, more.
We got a question for you from Dean here.
Yeah.
If testing random, why not create a random interface and mock it so you can control the number returned and test each random case you want to?
Yeah. There's multiple ways of doing good design and managing that kind of concern. That would be definitely a way. There are times when you may not control certain things. You're using a third-party library for which it's using random or some kind of random or pseudo-random like number. You know what the expectations are, but you don't have full control over it. So there are times when using Hemcrest is a good way of managing that concern. But I'm with you. If you can build in your designs in a mature way and manage it through mocks, then I'm all for that. So good question. Good call out. You'll also see there's a ton of things in here that I don't tend to go into. That you again look through the example here. I'm going to call out one, maybe two, and then move on to mocks. Some people are like, well, I already have some really good tests. I'm already real familiar with, say, with Mockito or JMockit or my favorite thing, whatever your favorite thing is, right? Or why would I learn to use a dynamic language as opposed to a statically typed language? Well, here is a great example. When you have a need to maintain libraries that span multiple versions of Java, it gets really, really hard. You want to be able to be at Java 11, but you got people on the bleeding edge going to 16, and you still have your enterprise developers on 8. And you have to separate out your repositories in a really challenging way oftentimes, especially in the open source space. This is true in the enterprise as well, so don't take that incorrectly. So how would we manage that here? Well, the first thing is if I'm using Java 7 or 6 or 5, I could still, in a dynamic language, it's just not evaluated until you run it. So what I can do is I can say ignore if not Java 8. And so I have something here that literally won't run that test unless the platform supports it. But I can also say, these are just the opposites of each other. It requires Java 8. So Java 8 and above will work fine. So if we were on Java, say, 7, the streams just didn't exist. This would have a gray line under it because we're not on Java 8. And it doesn't have that in the libraries. And it does exist when we're on Java 8. So here I can include a set of tests in the same repository that are run with multiple versions of Java, where we get extended tests when we're on a Java 8 platform or above, and we are ignoring it essentially when we're running it on Java 7. And this is just phenomenal. And I can do the same or similar things. Here you see JVM. I could use OS, so I can have extensions that are Windows, that are run only if I'm on a Windows platform or only if I'm on a Linux or a Darwin platform. There's some really great features here that work so great with a dynamic language that would just be challenging or impossible to do in a statically typed language. So that's just a call out for the value of using a dynamic language in this space. Some things that I don't tend to talk about, but since we're here, there is a function called old. And here you can see when a list has a value added. So here we have 3 elements. We're adding a 4th element. I can see that then the list is equal to 4, the sizes. But I can see also that the old size is equal to 3. So the old actually provides an encapsulation, if you will, or a cap enclosure of values that existed previously. And then we can make the comparisons in the assert. One of my favorite things to do, here's a hash map in Groovy. I could do something like I have a key that's equal to a value. I can then reset that key to a new value. And maybe all I really care about is that the value of the key is not equal to the old value of the key. I just want to know something changed. This is like a really terse way of doing that, right? So pretty awesome stuff that I can capture that. And I have some really advanced stuff here that I don't know if I'll dig into, but just go look at the code. I have actual closures in a where body clause that go to like taking this to the nth degree, just as this is how you can do something. All right, let's look at mocks. Now, I think I'll be low on time, so I'm gonna actually just dive into mocks. I was gonna compare it to JMockit and EasyMock. I might hold on that, we'll see. So mocking, what can we do? Well, here, first of all, I have a subscription 1 and 2. They're equal to the mock of subscriber. Here I'm mocking an interface. I'm adding to the publisher the subscriber. And then, notice a couple of things. First of all, this is a given when then. But notice I didn't use a given. If I do not provide a given or a setup, it is still a given. If you just start writing code, it is your given or your setup. It is not until you run into another block of code that you have transitioned into another block of code. So commonly, I leave that out. I'm a little bit more terse with things. I just don't care about that element. So here is the given. We have a when, this is fired. And now we get a little squirrely, right? 1 time. Now, what I think is really great is I bet people who are new to this can generally read it. It is 1 time subscriber will receive an event. Great. Now, what do we expect with mocks? I have to break this down into a couple of different ways of looking at mocks. The first is when any kind of mocking, what you have is 3 different stages, or at least 2 stages with the separation. So the first stage is what I call the recipes. Expect these things. Or when you get this, reply with that, right? So it's a set of recipes of how things should be orchestrated. Then there's a point of delineation. That's an important element. It's like, hey, we're about to actually really do this. The second is the stimulus, this phase where the event occurs. And then the third phase is verification. Was the recipe followed in the way that I described it? So that is very, very common. I can show you a bunch of, should I? I don't know. Yeah, it might be fun. So JMockit, what do we do? JMockit is horrible. Don't hold me to that. I'm sure somebody worked on it hard, and so I know how hard these can be. But let's pick it apart a little bit. Here we have that one, expect once that the has inventory has been called. Now, first of all,
I gotta ask you to bump your fonts. That's a little small there. So.
Oh, yep. Thank you.
There we go. Thank you.
Yeah, I appreciate that. You'll see that I'm a Scotch drinker. So, but notice here that I have a string representation of a function, has inventory. It's got to be cased right. The refactoring here is just super painful. But notice what's happening. We have the setup of expectations, that recipe I called out. We have, when we call or ask for the proxy, we're actually passing in the proxy to the object under test, which is this order. And then we're going to verify things. All right. So, and it tends to be that when we're using mocks, we want to verify 2 things. One is verify behavior. And then I also may want to verify side effects or state of things. And I usually like to separate those out. So here you can see that there's a lot of code to verify an order and its functionality. Here it is with EasyMock, which is a little bit better from a refactoring standpoint. In that when I create a mock of this thing, I actually can make calls. I can actually say has and get some IntelliSense and go, yeah, that's the thing I want. I don't get that with the other tool, but with this tool, I can actually get IntelliSense to jump in because it knows it's an instance of that thing, which is really, really wonderful. But notice I have my setup of expectations. I then say, okay, use the mock. I then verify. So those 3 steps are very consistent. What would we do when we're working with Spock? Well, because we do AST transformations, the magic of Spock, we can say this is the setup. In other words, this is the recipe, and it's the assertion. Make sure that this happened. So we're actually getting both of those at the same time, which is really, really awesome. I think there's some additional slides. I don't know if I will dive into that. I think what I want to do is actually get into this example of mocks so we can play around with it and become familiar with it. So let me drive the font up again, and we'll break into some discussions around mocks. Now, I'm making the assumption that people understand the use case, but all we have is a publisher that has subscribers, and when an event occurs, it's going to publish that out to all subscribers. That's really simple. And in fact, if we dive into the code, here's the code for it. And this is Groovy at this point. So we have a collection, we add a subscriber, we have a fire. This was a lab type thing, but we're essentially going to iterate through all of the subscribers and say receive it. So that's fairly simple code. Here, I'm gonna go through some Groovyisms and some Spockisms at the same time while looking at how we might mock things out. So the first thing is I have two ways I can mock things. I can have a subscriber which is equal to the mock of an interface, or I could say this interface subscriber equals a mock. In other words, I can define the type of it on the left-hand side or on the right-hand side, and both of them are exactly the same. Just pick one. Stick with that model. I'm using it here in two different ways for demonstration purposes. Either one of those approaches works. I tend to like this top line 20, but it's again up to you, whatever you think is more readable. The second thing to note is I keep saying this is mocking an interface. The question becomes, can I mock out a concrete class? By default, no. But if you add in the libraries for the test libraries for CGlib, then you can. So it's just as easy as adding in some dependencies, and that's it. And then you can mock out concrete classes as well. So where are we? I can say one time I have a subscriber one receive an event. Now this is a string that's being passed in. We're asserting. What are we asserting? In fact, let's say that this should be called twice and run it. What we're asserting is that the number of times it was called is true. We're also asserting that the value that was received is true. And so what we can see here is too few times this was called. It says that it should be called 2 times. It was only called 1 time. You can see that the error is actually really easy to read and understand. So this would be the type of failure you might see. Make it clean up again. So I'm going to run essentially the same test in multiple ways. I just want to keep changing it to show what's possible. So here I have, I'm mocking out 2 subscribers. I have a publisher, but in this case, I'm using the Groovy operator to insert the value into the collection. This would be what I would likely see in the Groovy world. So that's a Groovyism. What else am I doing? Well, I'm saying that subscriber 1 will have the receive method called, but I don't know what's passed into it as long as it's not null. I don't care. So this would pass as long as what is passed. And of course, the string is what's passed, and of course, it's not null. Here, I go a little bit further, and I say, hey, what I know is the thing that's passed will have a contains method, and the contains method will return true if I pass the contains Eve. So notice how dynamic this is, because it could be any object that has a contains function. I could go further with this and say, well, this is, if I don't have my cap locks on, this is a string A. And now I'm actually asserting that this is not only an object, but a string. And of course, a string has a contains function. So it depends on what you want to see there. But as long as this returns true, that's good. So here I'm passing an entire closure to the receive function. And as long as it passes and is true, this asserts to be true. I'm going to go a couple of steps further now. And the first is this would be more like what I would see in Groovy. I have 2 things I want to add to the collection, and we call this chaining. We're going to chain the return of inserting a value returns the collection, so I could keep chaining the assertions of values into that collection. That's not the more interesting part, but this is a very Groovy thing to do. What I didn't tell you is that the mocks, the verification on the mocks are in Regex. So you could say that subscriber 1 will one time have anything that starts with REC, and dot star in regex means any number of characters after it. So any function that starts with REC and doesn't have a null pass to it is what subscriber 1 will do. So anything that passes that test is fine. In the second case, I have subscriber 1 that will receive something. There is an underbar in Groovy or in Spock. The underbar is overloaded in Spock, and it means anything. In this case, we're saying that it's anything as long as it's a string. So I'm casting this type as a string, but it could be anything. Now, I could just as easily say anything. And I could also say that it's anything and anything else. So I could keep adding the number of things I don't care about to that list if I wanted to. I could also say star anything. Why you're doing that to me? And what star anything means is any number of parameters. I don't know how many parameters are. I don't care. I don't want to fill this all out. So star underbar, right? So that's completely legitimate as well. Also, I have two then. So let's talk about that for a second. Now, the one thing that is different in Spock that is quite different than other mocking tools is that in most other mocking tools, you care about order of things. It is Peter's position, the creator of Spock, that oftentimes you don't care about the order of things. And so there is no compliance to order within Spock, unless you want that. And so there is more verbosity, if you will, when you want to express that. So what does that mean? Well, in the case here, let me clear this out so that it is what we had originally as string. If I could type, if I wanted to guarantee that there was order, I could say then. Now, what this says is that subscriber 1 would be called first, and then subscriber 2 would be called second. This guarantees the order. It would only pass if it was run in this order. If I don't care, I could get rid of this then. Now, a common thing for me to do in some cases is if I'm testing out an API, I might say then 0 times, 0 times, that's what this is, 0 times, any mock, so this underbar is used for a mock, will have any functions called. So it's basically saying that these are the things that will happen, and nothing else will happen to this, any mocks that are involved with this test. So which is another way of saying that it is possible to say any number of times, any mock could have any function called with any number of parameters. That's completely legitimate Spock code, and I hope you never write that. But it is, from a lexicon standpoint, is legit. So there's a lot going on there. One, we've introduced regex. We have full regex capabilities. Again, the goal isn't to make things not readable. The goal is to make things easier. So use it where it's appropriate. Don't use it where it's not. But you can see the flexibility of being able to mock out certain things. Let's go another step further then. Since I already told you that I could have an underbar represent mocks, the only difference that you see here is I say 2 times a mock will be called with a receive function that has an event. This is a completely legitimate thing. We have 2 different mocks. One was called one time, one was called a second time. This captures that. 2 times a mock will have a receive function called with an event string. So that's pretty out there, but also cool. All right, let's go another step further. And that is to say we have a then again. But in this case, what I want to verify is that when the subscriber 1 is called, what I want that to do is, what is this? The shift left operator for you Java folks. Well, it is a way of defining a body of code that will be used for this receive function. If you're returning just a thing, it is possible to just return a thing. So I don't have to have a body of code if I have like maybe an account object. But if I wanted to actually execute a body of code, I actually could go through here and create a whole body of code and do whatever you want. Blah, 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 right? But a terse way of doing it is to say, hey, I want to see if I have a bad citizen, subscriber 1 is a bad citizen, that no other citizens are affected. So if I have an exception that's thrown here, all I want to do is make sure that subscriber 2 is also called. That's why we see a then. This is enforced to be first. This is enforced to be second. This was called on an exception when it was called first. And I want to know that this still is received after a bad citizen was injected into the publisher. Does that make sense? Is that cool? Did you get your money's worth? I hope so. All right, I might pause for some questions because I'm about to go. Let's go. I mean, I'll stop and take questions if people have them, but I'm going to go a little bit deeper with some mocks and show you maybe something that might be closer to reality. So I'm showing a couple patterns that I'm hoping would be familiar to Java folks. I have an account service, which is going to use an account DAO. We're testing the service for the most part. We're mocking out the DAO. We want to guarantee business behavior. What does that look like? Well, here I've mocked out an account DAO, which you can see a couple of options there. Here I'm going to create an instance of the account service impl, and I'm going to set the DAO equal to the mock. So now I've mocked it. When we deposit an amount into a number, an account number, an amount, then we've got some mocking to do, right? Okay, and we have a where body clause. So let's walk this through. What's happening? Well, first of all, we have this with. So with mocks, this is a way of not where I don't have to say mock dot, mock dot, mock dot. I can just say with this mock, one time the find account will be called with something, and it will return an account object. And one time the update will be called with something. We don't care. 0 times will we ever create an account when we're depositing money. We only deposit money for existing accounts. Now, I told you sometimes I use the and, and here's when I commonly will use it. When I'm mocking things, I commonly want to define behavior, my assertions of behavior, and I also want to assert state or side effects. So you can see here that I'm doing that. Everything between then and the and is behavior that I'm expecting. Everything after the and is the account.balance equals the total. You can see that I'm running this test twice. I have the 101 account and a 101 account. I have an account object that was created with a balance of 100 and a balance of 0. I'm depositing 50 in each one of them. And here's where you might likely have a double bar because the total is used and that's used in the calculation. So now we have something that looks a little bit like what I would expect in today's world of Spock. So that's a lot going on. I'm using the with on the mock. I could use with in other places as anytime you want to work on a particular object for a variety of properties that might be within it or functions or mocks. And I have a where body that's driving 2 tests of this functionality within this case. Some things that we haven't talked about yet. You've only seen me use 1 or 2 as the cardinality of the mock. Here we have a similar type of test where I say, well, any number of times up to 2 times this find will be called. And if it's called, return the account. Any number of times I could have the update account called. 0 times will I have a create. Here we're going crazy with the regex. Again, it's demonstrating what's possible, not what is best practice. But here we have a mock, which will have an update or create account. So this could be the update account or the create account. So be clear about which of those, but be clear of your regex. Be well experienced in that space. And then you can see that I'm doing some testing and a couple of other examples here. And this is pretty close to what I might write in the real world, by the way. So I'm going to find an account. I'm not going to create an account. I'm going to then update an account so I have a separation of when things will happen. And then I have a last then, which is 0 time will anything on the mock be called. So after I verified that this update has occurred, nothing else on the mock will be called. It's a verification that nothing, as code changes, we want to verify that that it's changed in a way we expect. I guess that'd be a way of saying it. There's one thing I left out, and I think I have it defined in some of this somewhere, and I must have missed it. Let me go back to my publisher, to the publisher test. I shouldn't be clicking around really, but It is possible to return things, as you see here, and I have some notes in here. So it is possible, I'm going to make this as big as possible. It is possible to have 3 chevrons here. What does that mean? What it means is that when I have a subscriber 1 called, the first time it will use the first element of this collection. So that in Groovy, this would be a list. I have an OK. The second time it's called, it'll be OK. And the third time and all times after the third time, not OK will be returned. So this is a way that the 3 chevrons to the right means that I'm going to change the value of what is returned on subsequent calls within the same test, and that's important. If I have a data-driven test with the where body, that the second test is a whole nother test. It is not the second run of the mock. It is when you're testing within the same test, multiple calls on the same mock, I could have different results coming back. You will be stuck on the last result on any more than 3 in this case. So, man, that's a lot to go through. Let me see if I missed something on the slides. We have the where body. We've talked through that. We've got some helper functions. This is if you have the same assertions you want to do in multiple places within the code. We did some demos. We talked about several of those. Just follow up on these slides, if you will. I'm not going to dive through them here. But later on in these slides, I actually break down a lot of details on mocks, and I'll dive into like the cardinality of things. I'll break it down. There's a cardinality of 1. There's a breakdown of different options, the target, the fact that we can use regex on the method constraints, or say anything, the argument list, the return types, a variety of things. A lot of these, when I first created this, didn't exist in documentation. So as far as I know, there are a lot of people that were coming to my class. I've had people that have using Spock for a couple of years and still have walked away with something. So hopefully that is the case here. I'm going to start to wrap things up and open up for any questions that people might have. Whether that, oh, you know what, it would be worth calling out this book. I was actually first tasked to write this book, and then I found out I couldn't write this book and also have a full-time job, and then Rob took it over. It's a great book and worth looking at. It's a little bit dated now, but most of the stuff hasn't significantly changed. It's still worth reading if you are new to this space. If you want to get a hold of me, it's just Ken Sipe on Twitter, kensipe@gmail. I'm also on Kate's Slack, writing Kubernetes code quite often as well. So, questions, comments? Love it. Nobody. All right.
So my Chrome was frozen, or I would have piped in there and given you a bunch of questions. But I love the whole Spock notion, and that you played that up. So do you have any good Star Trek trivia or puzzlers for the audience?
Well, I don't think anything that would be. I think some easy stuff, right? What shirt is worn? What person is wearing what shirt that is beamed down to a planet that you're most concerned with? What's the color of his shirt or her shirt?
All right, so that's going to take a while. I'll ask you some other questions along the way because that's
right.
we do have a delay. So you mentioned Jeb, and I've played with Jeb before, right? GEB.
GEB,
and it's not a protractor tool, is it? It's more of a WebDriver tool, so it's not really
that's right.
tied to protractor or anything.
I'm not familiar with what you mean on the protractor.
Well, protractor is from Angular, and it was like a wrapper around WebDriver, and they've deprecated it. So I was just personally interested in that if it was for protractor, but I don't think it was. So I got a good one for you. Your favorite Groovy tool?
Oh, it would have to be Spock. closely related with Gradle. Those are the two that I commonly use on Java projects. But I probably would say Spock first.
Cool. And then the other one that I don't know how many presenters there are on this, presentation or listening or watching, but maybe we'll get some. Before we started, you had basically shown me that all your fonts and all your applications were really small, and then you use some sort of tool to make them bigger without actually changing your resolution. So what was that tool? I'm curious about that.
Yeah, so first of all, most of what I changed was IntelliJ, and I'm on a Mac, so that's important to know. But it's really just a gesture on my trackpad. So if I squeeze in, it goes small. If I squeeze out, it goes wide. It literally is that. I think there might be a property to set that, but it would be easy to find. The same thing over, like when I was over on my terminal, this is iTerminal, I thought I might do some things out here. Everything that I do, like if we wanted to run tests here, I could just do that. It would run it. If I wanted to bump fonts, it's just Command plus, and then I'm like bumping up fonts to crazy space if we need it.
Now there was something else. You have like a Tesla icon up there in the top that you're using.
I'm sorry. Okay, so that tool, that's what you're referring to. So when I'm getting set up, sometimes I want to make sure I have something called Divi. So I could just say, it's a Windows manager. So I can go, I have some presets, but I could also go in here and go, well, I want this to take the full screen. And then it does, right? At whatever font it's at. Yeah, but Divi I use all the time. I also use iTerm. So like while I'm here in iTerm, I might hit like Command Shift D, and I have a second terminal while I maintain the first. So if I start up, spin up something, it's just super handy.
That's like,
I'm also using Oh My Z Shell with Power 10x along with some nerd fonts. So this, where I see that I'm on the master of Git, and I see that like if I hit something that doesn't compute, I can see that I got an error 127 out of it. I have the whole focus is from the terminal. I have instant awareness of what's going on. So if I were to say break out to Ken blah. So I create a branch. Now I can see I'm on the Ken blah branch on this project. It's just super beautiful.
Nice. So we got a question from Caleb here. Hopefully I'm saying your name right. Do you see a world where Spock is no longer necessary because Java is making some syntax moves release to release?
Yeah, that's a good question. I don't know the answer to that. I still feel like the power asserts, along with some of the notations, that the AST transformation is the magic. So until we have a world where Java can actually have that AST transformation, I still see some value in Spock. The additional thing is it's a dynamic language. So to put it on a platform that based on dynamicism, it knows that it should run or shouldn't run while being in the same code base, there's just huge value there. And I don't see Java moving into that space. It would be worth noting, though, where you can't use Spock, which I didn't say, and Caleb, thank you for asking that question. Spock has problems if you're trying to mock out static static objects or static methods and such, right? So if you fall into the space where you have statics, you're going to run into troubles with Spock, and it's a known edge case that just doesn't work. It could tell you that you don't have good design, but there are cases where you might want that, and Spock doesn't do it. Well, let me rephrase. I can mock out static Groovy, but I cannot mock out static Java. So,
all right, that makes sense. And we got one answer to the trivia here. Gold is Captain Kirk. Red was security engineering officer. I can't quite read the other one because Chrome is freezing up and not allowing me to click on anything.
And which one of those colors are you most concerned with being beamed down? Oh, there we go. I love
yeah, gold, blue, and red.
That's awesome.
That's not really the answer we're looking for, though, is it? You wanted one of those.
Greg answered in the channel. Yeah, I guess it's a private channel, though. Red is your biggest concern. Never wear the red shirt. Never wear the red shirt.
Nice. Well, any last words before we wrap it up?
No, hopefully people are staying safe and dealing with this with as much as we can as humanity. I think it's important to recognize that this is a challenging moment in our history where I think we're set up to have some mental health issues, and so that should probably be less taboo. We should just take care of each other. But if I left with anything, it's just be kind as much as you can.
That's awesome. Thank you.